Hi, in this short video, I will be briefly explaining my experience of designing surface electromyography electrodes and prosthetic hands. I started designing SEMG electrodes as part of my PhD thesis. Initially, a set of four variable electrodes were designed. These electrodes picked the signals from silver chloride metal plates, which were then amplified and fed to a microcontroller for further processing. The average of all four channels of SEMG signals was extracted to control 2 degree of freedom mechanical system. SEMG thresholding was utilized to control the movement of the wrist and the hand open and close action. To improve the robustness of the electrodes against movement artifacts and noise, the electrodes were redesigned such that the amplification and rectification stages were mounted on top of the signal pickup plates. The electrodes were mounted on an elastic band for reliable contact with the arm bulge, and the electrodes were free to slide along the band so that they can be conveniently positioned. I also designed several different multi-fingered prosthetic hands. Each finger had 3 degrees of freedom. However, only 1 degree was actively controlled while the remaining were passive. The thumb had 2 degrees of freedom. This hand was produced using selective laser sintering. In another design, consisting of 2 degrees of freedom fingers and a thumb, the motor for actuating the thumb was placed inside the thumb itself so that 2 degrees of freedom movement can be easily achieved. This hand was controlled using a DRV8830 based driver, which actually controlled the torque to the motors. The latest version of the hand has 3 degrees of freedom fingers and 2 degrees of freedom thumb. Each finger is individually controlled, and each degree of freedom of the thumb is also individually controlled. The motor driver is actually embedded inside the palm of the hand. Now, all of these designs have some limitations. For example, even the latest hand, the finger must be constantly driven in order to exert torque or grasping force on the object that has been grasped. So currently I'm working on improving the design so that there is a locking mechanism and the motor should not be constantly engaged. I have also designed a variable system which consists of basically a four-arm board and an upper arm board. The forearm board consists of an ARM Cortex M3 microcontroller and an inertial measurement unit, which is basically an MPU 9250. So basically, this board calculates the forearm quaternion and sends this data to the upper microcontroller. The upper microcontroller is an ARM Cortex M4F microprocessor, and it also has another IMU. Using this IMU, it calculates the quaternion of the upper arm, and it also calculates the entire kinematics of the forearm. So basically, it integrates the two quaternions, and using simple kinematic relationships, finds the position of the forearm and the elbow in 3D space. Additionally, the upper arm board is also connected with four SEMG electrodes that I designed myself. Now, the entire signal processing is also done by the same microprocessor, and it basically extracts four time domain features, which are actually the moving average, the IEMG, the waveform length, and the slope sign changes. Then all of this data is transmitted in real time through a Bluetooth module to a PC, and actually a LabVIEW software that has been designed. The LabVIEW software basically displays the 4-channel EMG data in real time. So you can see all the 4 channels. As I move my flex and unflex my fingers, you can see the changes in the EMG signals. Additionally, the forearm kinematics and the elbow kinematics is also displayed in real time. So if I move the forearm, you can see the variation in the velocities. And if I move the elbow, you can see the variation in the elbow as well. Additionally, all the parameters are also displayed in real time for debugging, so that you can see if there is anything that is not normal. Additionally, you can log all the data by choosing a file here, and so that all the data is logged to a text file. And you can also provide a gesture from this list, whether you are using a spherical gesture, lateral gesture. You can add as many gestures as you like. So basically, this software logs the 4-channel EMG data, the forearm position, the elbow position, and the forearm velocities and the elbow velocities in real time in a text file, which can then later be processed for training of neural networks or any further processing. Thanks a lot for listening to this video.